Namaste, Bachcho. Hamisha Kushavu. Myself, JVWU, Dr. Monica Chirudi. I'm from Department of Science, Faculty of Education and Methodology, JVWU, Women's University, Jaipur. So today I'm taking the class of DETCS second semester. The subject is Applied Chemistry second. And today I'm going to discuss about the calorific value, the definition, the classification of calorific value, as well as how we can determine the calorific value by the theoretically, or we can calculate it from the experiment. So in today's class, we will discuss about the calorific value of any kind of fuel which we are using to combustion. Okay. So as we know that the calorific value is the amount when the fuel is completely burned. So some kind of heat is liberated. So what is the calorific value? When the fuel burned completely, some amount of heat is liberated. So the total amount which is liberated by the unit mass is known as the calorific value. Okay. Now, what is the efficiency of fuel? So the efficiency of fuel is also related with a calorific value. If the fuel show the good amount of calorific value, it has a good efficiency. Okay, so for example, the wood is a fuel, and when we burn the wood, it will some kind of energy or some kind of heat. Okay, so the wood has a calorific value near about 17 kilojoule per gram. Okay, so this calorific value shows the fuel is efficient or not. Okay, so we can calculate the calorific value in units like calories, kilocalories, British thermal unit, and centigrade heat unit. So these are some units which we can measure the calorific value for any kind of fuel. Okay. So now the types of a calorific value. As we know that the total amount which is liberated by the fuel when it burns is known as a calorific value. So if we burn the fuel, like if the fuel contains hydrogen, okay, so this kind of fuel shows two type of calorific value. First is a high or a gross calorific value, and another is lower or a net calorific value. You know that high means a good calorific value and low means bad or a low calorific value. Okay. So first we will discuss about the high calorific values. What are the high calorific values? Okay. So high calorific value are also defined as the total amount of heat, okay, which is liberated when the unit mass of fuel is burned completely. Okay. When fuel burn completely, some amount of energy liberated, and this amount of energy which is liberated by the fuel is known as a high calorific value. Okay. Now, this liberated amount or this fuel is which is combined is cooled on a room temperature. Now, the heat we can calculate this heat, and the heat calculate in a some unit like calories, kilocalories. If the fuel show the good amount of calorific value, the good amount of calorific value, it is belongs to the high or a good calorific value fuel. Now, when a fuel which contain the hydrogen or when it burn, so it will give the steam. Okay, when hydrogen is burned, it is completely burned and it will give the steam. Okay, now this steam is cooled at the room temperature, and now this steam condensed to a water. We know that whenever we boil the water, it will become a fume or like of steam. Okay, and when we condense this steam we will get the water again. So uh, uh, if the fuel containing water, when it burns, it will convert into a steam, and this steam can produce on the cool or the room temperature, it will condense into the water again. So in this process, some amount of heat liberated, and this heat known as a latent heat. Okay. If we calculate this heat, we will get the gross calorific value of a fuel, and this amount, if we it shows a good amount. Okay, so that means that the hydrogen fuel is a good fuel also. Okay, so as well as we have a good or a high calorific value or gross calorific value, the fuel is also in a category of good fuel. Okay. Now, the second is a lower calorific value. What is the lower calorific value? Okay, so the lower calorific value is also defined as the net heat production. Okay, when a unit quantity of the fuel is completely burned, when the unit quantity of the fuel is completely burned, this produce some kind of heat, or and in this case the product which is produced is on a combustion is allowed to escape. So in a normal condition, what happened, the water vapor produces during the combustion. Okay, and this water vapor can condense and form the water. But in the lower calorific value, what happened, in a normal combustion process, it will show the water vapor, and by the combustion it will not it will just escape by the hot gases. Okay, so hence there is a low amount of heat which is available, lesser amount of heat which is available to calculate the calorific value. So the in this case of lower calorific value, we will get the lower or a net calorific value, which is a lower or a lesser as compared to the higher calorific value, because the product which is produced by the combustion is allowed to escape. So we don't have that much amount of product, so we can calculate the heat which is evolved by the combustion process. Okay, so we will get the lower amount of the calorific value. So this kind of process known as a lower calorific value. Okay, now we can calculate the calorific amount of any fuel. Okay, so if we have to calculate the net calorific amount or net calorific value, we have to use the simple formula, which is the net calorific value, which is equals to gross calorific value, which is also a high calorific value, subtracted by latent heat of water vapor, the amount which is liberated by the water vapor. Okay, which is known as a latent heat of the water. So you can also use this formula like the net calorific value, which is equals to gross calorific value subtracted by weight of hydrogen multiplied by 9 into multiplied by latent heat of water vapor. The latent heat of water vapor is 587 kilocalorie per kilogram. And here the hydrogen in this fuel react with the oxygen to give water. Okay. So by this formula, we can calculate the net calorific value for any kind of fuel. So for example, the water combines with the oxygen and it will give the water molecule. Like the H2 plus half O2 will react and will give the H2O molecule. Now, what happened if we can also write this form like 2 hydrogen here, which is equals to half O2, which will react with each other and it will give H2. So the 2 hydrogen is equals to half mole of O2, and which is equals to 1 mole of H2. Okay. We can also write this equation like 2 part of hydrogen, 16 part which is equals to 16 part of O2, and this is all equals to 18 part of H2O molecule. Okay. For 2 part, if we talk about 1 part of hydrogen, so we have to subtract by this equation by 2. So now if we talk about 1 part of hydrogen, we can write it like 1 part of hydrogen is equals to 8 part of oxygen, which is equals to 9 part of H2, because 1 plus 8 is equals to 9. So in this equation, 1 part of hydrogen combines with 8 part of the oxygen, and it will give the 9 part of H2O for the water molecule, which is a product. Okay. Now we can also calculate the net calorific value by putting this value in a net calorific value uh, equation. Now we can calculate the calorific value for this reaction, like NCV, which is a net calorific value, which is equals to GCV. GCV is a gross calorific value subtracted by 0.09 hydrogen. Hydrogen here is a as a fuel, which is multiplied by the latent heat of the hydrogen, which is 587. So by putting this values in this equation, we will get the total or net calorific value for the hydrogen fuel. Okay, so this is the experimental calculation. Now we can also calculate the theoretical calculation of the calorific value, okay, by the Daglong's formula. Okay, we know that the both hydrogen and oxygen are present in a fuel. So if the oxygen combined with the 1/8 moles with the hydrogen to form a water. Okay, now what happened in this formula? So we can also use the Daglong formula for this fuel combustion, which contain the carbon, hydrogen, oxygen, and sulfur, and we calculate the calorific value for the hydrogen fuel. Okay, so we have to calculate the calorific value for a hydrogen fuel, which contains the carbon, hydrogen, oxygen, and a sulfur in a percentage form. Okay, so we have to put the value like calorific value, which is equals to 1/100, and 8080 of percentage of carbon plus 34500 of hydrogen, which is combined with 1/8 part of oxygen. So we can write here oxygen by 8, and the 2240 percentage of the sulfur, and the unit is kilocalorie per kilogram. Okay, this 8080 of carbon is a percentage here. Okay, so the carbon, hydrogen, and sulfur present in a percentage form in this fuel. So by putting this value in this Daglong's formula, we can calculate the theoretical value of a calorific value. So student, this is all about the calorific value. I hope you can understand what I am delivering here, and if you have any kind of query, please let me know. Please comment on my video, and I will resolve your all doubts. And thank you very much.